everyone, the function f of x equals 3x is defined on the interval 0 to 6. We're going to approximate the area from 0 to 6 by partitioning it into 6 subintervals, choosing u as the left endpoint of each subinterval, and also choosing u as the right endpoint of each subinterval. So I went ahead and drew the graph of the line y equals f of 3 of x. And then we want to first start with, let's just notice that we're going from 0 to 6. So we take 6 minus 0 divided by our 6 intervals. So that's going to be 1 each. So we're going to have each piece is going to be 1, equal to 1. So if we start from the left interval, and the reason what they mean by that is if you look at this, these are our endpoints here. We actually have 7. So we either have to start from 0 or start from 1. And so when they're talking about the left, they're talking about we're going to start at 0. Well, there's nothing there for 0. So what they're going to do is start, you start from 0, but then now we're going to go to 1. And 1's going to go up to here. Then you go to 2, to here, go to 3, to here, go to 4, to here, go to 5, up to here, and go to 6. So I'll just go ahead and draw down here. So you basically, with this one, you have 1, 2, 3, 4, 5 rectangles. Now if we do the left, we're starting at f of 1. So we're going to go from 1 here, go up, and then draw to the left. And then from 2, you go up here, draw to the left, and you can connect like that. 3, you go to your y value, draw to the left. 4, go up here, draw to the left. 5, whoops, hard to draw straight, go to the left. And then 6, let's see if I can get that. So 6 comes down here, I can't get it very well. And then you go up here because I'm at the end of the page. There we go. So there's the difference between the two. This one is you're using your left endpoints, and this one is using your right. All right. So basically all you do to approximate the area is we're going to take your area is approximately, and we're going to use this 1 to multiply since that's our subintervals going from 0 to 6. So you're going to do, we started at 0 for the first one. So we're doing this. So that's going to be f of 0 times 1 plus f of 1 times 1. That's this one. Plus f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1 plus f of 5 times 1. So we're only going to 5. So we're only using these 1, 2, 3, 4, 5, 6, these endpoints. All right. Now, when you evaluate this, you're going to get 0 times 1 plus 3 times 1 plus 6 times 1 plus 9 times 1 plus 12 times 1 plus 15 times 1. So basically it's just 3 plus 6 plus 9 plus 12 plus 15, and that equals 45. All right. Now let's do the right endpoints. I'm going to leave this on here. It's going to look like I'm going to erase it, but I'm going to copy it over, so if you want to go through the video, you can look at it. But I'm going to duplicate the page. So it's going to, oops, I duplicated it wrong. So let me duplicate the ink so we can get that, and then I'm going to erase this. But this is on the other slide there. So if you want to go back, it's going to be there. All right, so for this one, we're starting at f of 1. So what we're doing is we're using these endpoints, 1, 2, 6. Yeah, be real careful with that one. This one is, I've got 2 loads to the page there, so that one right there. All right, so we're going to do the same thing. It's going to be the area is approximately f of 1 times 1 plus f of 2 times 1 plus f of 3 times 1 plus f of 4 times 1 plus f of 5 times 1 plus f of 6 times 1. We'll do this. All right. So I'm not going to keep multiplying the ones. This is just going to be, this one's going to be 3 plus 6 plus 9 plus 12 plus 15 plus 18. Okay, and then they also want us to find the actual area. Well, the area of a triangle is 1/2 base times height, which is going to be 1/2 6 times 18, which equals 54. Oh, and this was 63. Sorry about that. This one was 63. So this is the actual area under the line y equals 3x. And that's it. Thank you. Have a nice day. Bye-bye.